Hello and welcome to our webinar. Today we're going to talk about deploying Oracle RAC, specifically version 19c, on AWS using a FlashGrid product called SkyCluster. My name is Art Danielov. I'm the CEO and CTO at FlashGrid. So I will be presenting the webinar today. And if you have any questions during the webinar, please email them at the address that is on the slide, webinar@flashgrid.io. And we will try to answer your questions towards the end of the webinar. So what we're going to uncover today is an introduction of what SkyCluster product is and how it enables running Oracle RAC on AWS. We'll do an architectural overview. And also we'll do a quick demo of how you can actually launch a RAC cluster on AWS. And also I'll show you how we'll show you a running cluster on AWS. So what is SkyCluster? So SkyCluster effectively allows you to have active high availability with 2 or more database nodes on AWS by leveraging the Oracle RAC database engine. The deployment is done using infrastructure as code approach, which simplifies the process and makes it very repeatable. It is effectively what we call an engineered cloud system. We have engineered it with high availability in mind. There is obviously no single point of failure. And of course, we do pay a lot of attention to reliability and performance aspects. We do rigorous testing with hundreds of cycles of failure injections, various unexpected failure scenarios, and load tests. And of course, we also pay a lot of attention to performance because if you are moving a large database from a high performance on-prem system, or you're just deploying making a greenfield deployment that needs to run in high performance, you can count on us to get the maximum out of your AWS infrastructure. And all this comes with 24/7 support, which is obviously critical for highly available mission-critical systems. Now let's take a look at the architecture. On this slide, you can see that you can see a high-level view of a typical cluster. It is somewhat simplified, but it gets you the basic idea. What you're seeing here is 3 EC2 instances, and each instance has some FlashGrid software installed on it, and also Oracle grid infrastructure software that includes clusterware and ASM. And on top of that, you have RAC database instances running. There are 2 main software components from FlashGrid that enable this architecture. The first one is called Cloud Area Network. What Cloud Area Network does, it enables some more advanced network capabilities that are required for running RAC, but they're not available natively on EC2. And that, more specifically, those are the multicast, the virtual IPs, and transparent movement of virtual IPs between the nodes, and also quality of service with segregation of different types of traffic to make sure that each type of traffic gets a certain amount of bandwidth and the priority that it requires. The second piece of software from FlashGrid is called Storage Fabric. Storage Fabric effectively enables shared access to all the disks in the cluster from each node of the cluster. You can see on this diagram that there are EBS or local SSD disks attached to each of the EC2 instances. But as you probably know, those are not natively shareable in the EC2 environment. So Storage Fabric effectively takes those disks attached to individual instances and makes them available to the other nodes. And effectively, it exposes those disks to ASM, and we leverage the capabilities that ASM has for data high availability and for data mirroring. You can also notice that these EC2 instances are shown as placed in different availability zones. This is quite important because EC2 offers 99.99% uptime SLA for 2 instances running across 2 different availability zones. So if you want to make use of that uptime SLA for your mission critical applications, it is beneficial to have these RAC database instances running in different availability zones. For those of you who don't know what exactly availability zone means, it is effectively a separate, those are effectively separate data center buildings, maybe some 10 or 20 miles apart, that are transparent in many ways, but they provide physical isolation and help with surviving some local disasters. However, I should mention that in some cases we have customers who prefer to run within the same availability zone, and achieve their uptime targets by doing replication to a different region. So that is also possible. The SkyCluster architecture is flexible enough to accommodate both approaches. However, by default, we still suggest running it across availability zones, and that's what the majority of our customers do. Now, a few more words about the HA architecture of this solution. Like I mentioned, there is no single point of failure. There are you can have 2, 3, or potentially more database nodes, although 2 or 3 database nodes are sufficient and the most efficient in most cases. And there is also synchronous data mirroring done across the database nodes with either 2-way or 3-way mirroring. You keep the capability of doing the rolling patches, applying patches in a rolling fashion, whether it's database patches or the OS updates. And also this architecture protects you against failures and basically some unexpected failure scenarios as well, such as VM or physical host failure, some reboots that might be planned for host retirement or security updates reasons. In case you do run it across availability zones, then the cluster can survive a loss of an entire availability zone. And of course, things like database or operating system crash or system disk or file system corruption, those things can happen, and you want to make sure that there is no downtime as a result of that. So with SkyCluster and Oracle RAC, you can achieve that. From Oracle DBA's perspective, we try to keep it as DBA friendly as possible. So you get the full Oracle RAC stack, including ASM and clusterware. You get to keep the standard Oracle tools, such as RMN for backup, DataGuard for disaster recovery replication, Golden Gate for replicating between different databases, as well as Oracle Enterprise Manager. You still have full control of all the database features and the patching process, because this is not a database as a service. This is like a virtual appliance that you have full administrative control of. And the database patching process is standard, so there are no restrictions that we introduce. The good thing about this environment from DBA's perspective is that the storage, which is one of the expansion of storage, which is one of the most common maintenance tasks, is quite simple. You just add additional EBS volumes, and you just attach them to your EC2 instances, and they automatically get shared, get exposed to ASM, and can be added to ASM disk groups. And on top of that, we have a team of experts with very deep Oracle expertise that can help you with a broad range of questions that cover infrastructure and the database. Performance is an important aspect, of course, because, well, first you need to achieve certain performance metrics for your database, and second, you want to be able to minimize your costs. We support EC2 instances ranging from very small ones to as small as 4 cores per node, and all the way up to the largest bare metal instances that AWS currently offers. The performance of storage can also be quite high, and it depends on the type of storage you choose and the amount of storage you attach. With just standard EBS volumes, with GP2 EBS volumes, we have measured more than 100,000 IOPS in a 3-node cluster setup with a read-write workload. And if you need even more than that, you can achieve that by using local SSDs, where we measured 450,000 IOPS, which is comparable or even exceeds the capabilities of a typical all-flash storage array that you might have in your data center. But the good thing is that you can start with a size that makes most sense to you, and then you can resize it to the you can upsize it or downsize it if there is a need for that. Okay, so in terms of security and control, you have full control of both the database software and the operating system. So you have a root access to the OS. The VMs are deployed in the in your cloud account, and FlashGrid does not have access to your VMs or your data. And your data is can be encrypted at EBS level with either AWS or custom managed key. And also, if you prefer to use Oracle transparent data encryption, you can do that on top of EBS encryption. Compatibility. So we currently support database versions starting with 11.2 and all the way through 19C. However, the grid infrastructure is always 19C. So even if you start with a database version that is older than 19C, then you can pretty easily upgrade it to 19C, which has long time support, because you don't need to even worry about upgrading grid infrastructure underneath it. And you can run even two database homes with different versions at the same time. You also have a choice from operating system perspective between Oracle, Linux, or Red Hat. And we do support both commercial and US government clouds on AWS. Support is quite important for mission critical databases, and we of course realize that, and that's why you get 24/7 support coverage that includes that covers all the entire cluster infrastructure. And that includes FlashGrid software, as well as other infrastructure components, including Oracle ASM and clusterware, EC2 instances, networking, the disks, and also the Linux kernel components related to network and storage. Plus, we can also help you with performance, whether it's tuning or troubleshooting or sizing during migration. And finally, how do you create a cluster? So we have a tool called SkyCluster Launcher that basically allows you to do infrastructure as code-based deployment, which takes just about 1 hour. The good thing about this tool is that you can configure. It makes it easy to configure the first time, and it makes it even easier to do it to configure and deploy additional clusters, because you can reuse the configuration and make only the minimal adjustments that you need. And what's important is that this tool, because it fully automates the deployment process, it helps you eliminate the human errors, which are especially dangerous in high availability configurations, because the last thing you want is to configure your cluster and it seems like everything is working, and then when some failure happens, you experience downtime because something was misconfigured. So we help you avoid this type of danger. Now, let me actually show you how do a quick live demo of how the deployment process works. Give me a second to switch over. All right, so we start with the product page on our website. And under software, you go to see SkyCluster for AWS. And on this page, you scroll down, there are two buttons, launch two RAC nodes or 3 RAC nodes. So these are the two most standard configurations that majority of our customers prefer to use. We can enable you with larger configurations if needed. All that would require is giving you a slightly more customized template to start with, but then the process would be essentially the same from that point on. But in this case, let's just start with a simpler 2 RAC node configuration. So I click on this button, and it takes us to our SkyCluster Launcher tool. So this is the tool that guides you through a number of steps. Each step is quite simple, and effectively just need to answer a number of questions about your desired cluster configuration. So the first step is basically just selecting the name for your cluster and the region. So you have a full list of different regions that are available today. The next step is selecting the operating system. And you see here Oracle Linux or Red Hat. And you can also see here two links to the AWS Marketplace. This is where our product is listed, and it is effectively delivered through AWS Marketplace. So all the billing will be done on hourly basis by AWS. And if you follow one of these links, it will show you the product information, and you will see a button that allows you to subscribe to this product. So effectively, but you don't get charged until you actually start using it. The next step is selecting your database version. So yeah, you see here a full list of various database versions that are available, and you select the one that you need. And you also can select one of the release updates that are available. So after you have selected which database version you want to use, you need to provide Oracle installation files. As we fully automate installation and configuration of grid infrastructure software. However, we do not distribute Oracle binaries because you need to have your own Oracle license, and you have to have Oracle support subscription. And basically, we ask you to download your own copy of all the required Oracle files and upload them to an S3 bucket, to your own S3 bucket, and then during the initialization of the cluster, the initialization process will get these files from your S3 bucket and will install and configure them. The next step is actually selecting, configuring your database nodes. You can customize the host name, obviously. You can select which availability zone each node is placed in. And also you can select the size for your database node. And you can see a full list of various EC2 instance sizes that we support. You also will notice that there is a third node listed here, so-called quorum node. This is a small node that has only a single core and does not have any Oracle software installed on it. It serves as an additional storage location for a third copy of clusterware voting files, and also for a third copy of ASM metadata. The primary role of this additional node is to actually enable high availability and avoid potential split brain scenario. So in this configuration with 3 nodes, any one of these 3 nodes can go down without causing database downtime. So it's just a simple majority rule. 2 out of 3 nodes must be up for your database to be up. Next is storage configuration. Storage is defined in terms of ASM disk groups. By default, we suggest data and FRA, but you can always change the list of the disk groups. You can rename them, you can add additional disk groups, and more importantly, you can customize each disk group with how many disks you want to have in that disk group and what size of disks you will get. The type of disks that we use is GP2, general purpose SSD. That type of disk is sufficient in vast majority of cases. And because we can use multiple of those EBS volumes, we can effectively max out the throughput and IOPS capability of the VM by adding sufficient number of GP2 disks. And also, you get, compared to other EBS volume types, you get lower cost and still get the full performance that your EC2 instance can provide. Note that the grid disk group is created by default, so you don't need to worry about it, and that disk group will contain voting files and OCR. There are some additional parameters that you can customize, or you can just leave the default values. We automate configuration of huge pages, so you don't need to worry about manually setting kernel parameters. And it actually makes it easier, especially when you need to resize your EC2 instances. It's easy to resize the VMs, but reconfiguring all the kernel parameters might be an error-prone process. So we just automate that, make it easier for you. You can customize listener ports. The only requirement here is that the scan listener port and the local listener port must be different. With regards to network, you have 2 options available. First, you can just keep this VPC ID blank, and in that case, an entire new VPC will be created automatically together with the cluster, and that will include the required subnet and security groups. The benefit of this approach is that it just makes it much easier to deploy a cluster. So if you're just doing a POC type of deployment, just a sandbox environment that does not have to include other components, that's what I would do. Just makes it so much easier. However, in production environments, usually you would already have an existing VPC, and you want to plug your cluster into an existing VPC. So in that case, you just provide a VPC ID here, and then the cluster will be created attached to that VPC. Next, you can customize your DNS settings. Of course, you want to set a domain name that makes sense for your company. And also, if you prefer to use custom your own DNS servers instead of Route 53, then you can add those DNS servers here. You can also configure email alerts with just the email addresses where those alerts will be delivered. And you can add tags that will be attached to instances and disks just for asset tracking purposes. And that's about it. Now we're ready to validate this configuration to make sure it is consistent. And in fact, we are ready to launch the cluster. However, I would first suggest that you download this configuration that you have just created. So effectively, all the parameters that you have entered, you can save them as a text file on your computer by clicking download, and then you just keep this file. And next time, if you need to deploy a similar cluster, you don't have to start from scratch. You already have all those parameters, and you just can upload that config file and then customize a couple of parameters that you need. And there is an upload link in the top right corner. Now we are finally ready to launch, and let's click the launch button. So what happens at this stage is that the launcher tool generates a CloudFormation template, and it takes you directly to the CloudFormation manager. So here you can see this link, which is a link to the CloudFormation template. And basically, at this point, you just need to deploy it in your AWS account. Click next. There are a couple of more parameters that you need to choose here. First of all, it's the AMI ID, which actually is already pre-populated, so you don't really need to change it in those cases. It corresponds to the marketplace AMI in your selected region. And then you also choose the key, SSH key that you will use to access your instances. Also, if we selected to use an existing VPC, you would have a choice of subnet IDs and security groups here. It would allow you to choose from the list of the subnets and security groups that you already have in this VPC. Click next. There are some other additional options available that we don't really need or don't have to configure. So we'll just skip over, go next. And at this point, we are ready to create the stack. So I'm not going to create the stack now because it will take some time. But basically after you click the create button, it will create the EC2 resources, which takes several minutes. And after that, the software initialization process starts. During that process, the FlashGrid software is installed and configured on all the nodes of the cluster. The grid infrastructure software is installed, patched, and configured. The ASM disk groups are created, and the database software of the selected version will be also installed and patched. The entire process takes just over or about 1 hour, depending on the configuration. And in the end, you get a fully functional cluster with grid infrastructure running, ASM running, and it's ready for you to create a database. So you will see I have a demo cluster already created beforehand. So this is what it's going to look like. You'll have 3 EC2 instances. And we can connect to one of those instances. And when you connect to it, assuming that the initialization process has already finished, which, like I said, takes about 1 hour, you will see a message like this saying that initialization completed successfully. At this point, you can check all the you can check all the resources. So, for example, run this command, and you can see all the standard clusterware resources already up and running, as you would expect to see in a normal RAC cluster. There are also additional commands that we provide here, such as FlashGrid SkyCluster, that shows you status of the entire cluster, and also the list of all the nodes and status for each node, also the list of ASM disk groups and status for each disk group, and the overall status of the entire cluster. You can also dig a little bit deeper, and with FlashGrid node command, you can see more details about this particular node with the list of local disks or local EBS volumes attached to this node, and also the list of the other EBS volumes that are attached from the other nodes. Now let's also take a look at some details about particular disk group. What you can see here is all the attributes of this disk group, as well as where it's mounted, and the list of EBS volumes that are part of this disk group. So this concludes my demo. Oh, and one important thing is, of course, creating the database. So at this point, you're effectively ready to create a database. So you can just run dbca to create one, and then you can configure or you can restore the database from RMAN backup, or you can configure DataGuard to replicate your database from an existing cluster. So this effectively concludes what I was going to show you today, and I think we are ready to take some questions. All right, the first question is this a concept architecture, or do you have any production deployments? We do have quite a lot of production deployments, and in fact, we have customers who've been running in production for over 2 years. So yes, this is, and they're all very happy with what they get. So we have, I think, a few more questions. So let's wait for those. Do I need to log in to use the deployment tool? I guess that's the launcher tool at FlashGrid website. No, actually, the launcher tool is publicly available, so you don't have to log in. You can just start using it right away. Is it possible to get a free trial? Yes, absolutely. We have a 1 month free trial. So effectively, the way it works is that you get billed through AWS, but we actually refund those fees. So at the end of the month, we refund the fees for the prior month. So yes, you are absolutely welcome to do a POC, and we'll be happy to waive the fees for 1 month. Do you access my AWS account to deploy the cluster? No, we don't. We never get access to your AWS account or your EC2 instances. It is so basically you just use our tool, it generates a CloudFormation template for you, and then you deploy the template in your account. We do not need and do not want access to your account. Okay, so next question. Our database is on premises and managed by a third-party MSP. Can you work with them to help with moving lift and shift the cluster to AWS? Yes, we can work with an MSP. We have successful experience working with managed service providers, and we can help them with those advising how to do it and providing some support. All right, any other questions? All right, I think we are done. Thank you, everybody, for attending this webinar. And if you have any follow-up questions, please feel free to use this email, webinar@flashgrid.io, and we will respond to your inquiries. And we're always happy to help you in the process of deploying your RAC clusters on AWS. Thank you very much, and have a good day.